Hello everybody, today I want to show you how to set up wireguards on 3 Ubuntu systems. My goal is to connect the client 1 and client 2 to each other, and both of them are behind firewalls, and the communication should go through a server which stands in the internet, and the wireguard clients behind the firewall, they have a direct connection, wireguard connection to the server, and the server should route the traffic from client 1 to client 2. So let's start then. Over here I have 3 different terminals synchronized with the help of tmux, and we start to install wireguard with that command apt install wireguard, and we see wireguard is already installed on each of them. Nice, so we can proceed with to set up some aliases I made. So I don't want to show you my external IP address for my server and private keys and so on, so that's why I use these aliases. Now we shut off the tmux synchronization, go to the first client and set up the first peer. I shut on the synchronization again because let's switch to the directory etc wireguard, and there we want to create a file called w.conf. W will be our wireguard interface name. Then we switch into the insert mode, and now I shut off the synchronization, and we start with the first client and set up the interface address to 10.00.101. Save the file. Go to the next one. The next one is the server in the middle, so he gets the 100 at the end. And on the right side is the client 2, he gets the 102 in his address. Save the files. And now we can set up the tmux synchronization again. And now we generate the private key on each machine with the help of wg gen key command. The private key goes into the file w_priv. We don't care too much about the warning because we will delete the file soon. Now we need to bring up the wireguard interface with this command. And you see it uses the given addresses. We can check that by showing the wireguard interface, and you see we have a wireguard interface with the name W, and it has the correct IP address. But we can also try to ping the server. This will work on the server but not on the clients, so they can not talk to each other yet. Okay, now we can set up the private key. Here we use the recently created w_priv file, and we set up the listen port. And this is the reason why the interface has to be running at this point. If it would not run, we could not set up this stuff. And now we can check the wg status, and we see all the stuff we set up. The private key is hidden, and we see a public key which comes through the help of the private key we set up. But before we write down the public key in our commands, I will save the configuration to the config file w.conf, remove the private key file, and again we see we have a look at the status, which is the same like before. And now I will go through my document and specify the public keys which we want to use on the corresponding peers. I will take them and put them into the commands we need later on. So first of all, we copy the public key from the wireguard server, which is this one, and replace it in this document on all occurrences where we have the public key of the server. Okay, nice. And then we take the public key from the first wireguard client. This goes to the first peer of the wireguard server. And here, down here, we need it later on if we want to configure the preshared key. Then we take the public key from the second client, set it up as the identifier for the second peer on the server. Okay, that's done. So now we can proceed and up the status here. And now I want to show you something. I will set up then here the endpoint on the first peer on the client 1, for example. And the endpoint is an A record, but not really an A record. I set it up in my etc host files. It aims to the IP address which my server has. And I set up the endpoint to this name and the port 1820. They all are listening on 1820, so it's good so far. And let me show you what happens if I ping this name. And you see I get a response, so they can talk to each other. And have a look at the response times. The server itself doesn't need so long, sure, but the clients need both 15 milliseconds around. So then we start to configure the first client. Let me shut off the synchronization again. We put this document here, this command here, and then we save the configuration again to the config file. And now we can have a look with where the alias I made up, wg status, and you see that we have a peer configured. And the allowed IPs, this tells the wireguard interface if there came a request to these destinations, those both IP addresses, then please route the traffic over the wireguard interface. So if I want to reach the server, it goes through the wireguard interface. And if I want to reach the second client, the same on the others. Okay, let's go to the second client and let's configure him. I run both commands at once, and then we go to the server. I have there to set up 2 peers, one for each client, and that's why it takes the public keys from the clients. And now we can have a look if we can ping the server. Oops, let me set up the synchronization again. We try to ping the server from each system, and it's not possible at the moment. Then let me restart the wireguard interface, and let's try again the ping, and you see it works on each system. That the server can himself ping, sure, it's not we wonder not about it, but let's try to ping a client, the first client, and you see the second client cannot ping the first client. And why not? It's because the server cannot route the traffic yet. So there's a kernel parameter we can check with this CTL, it's this one down here. Let's maximize the server command line, and you see it's 0, and we can use this CTL -w and then the key and then equals 1, which means set up it to it's on. We can double check it. You see it's 1 now, and now we ping again the first client, and you see the second client can ping the first client. The same to the, we try to ping the second client, and you see the first client can ping the second one. And you see different response times, because the first client has the longest way, because he must go first to the server. It needs around 15 milliseconds, and from the server to the second client again another 15 milliseconds, so it is around 30 milliseconds and some. And yeah, that's it. Nice so far. And now it will be a bit complicated to set up the preshared keys. Why do we use preshared keys? The VPN connection is already encrypted, but it makes it a little bit safer. If we have preshared keys, then it's not possible to decrypt the traffic anymore by supercomputers and stuff. Okay, here I use a little trick then later on to publish the preshared keys to the server. Both corresponding peers need the same preshared key. So the first client gets its preshared key, and the first peer on the server gets the same preshared key, and the client 2 the same way. So what will I do? I will generate the preshared key only on the clients, and then I will transfer it with the help of netcard command to the server. For that I have the TCP port 51820 open on my server, and I will create a listener, and the listener will get the key with the help of netcard from the client, and it will write it down in a file so we can use it later on. So let me show you how it works. The synchronization is on. I shut the synchronization off again, the TMUX synchronization. And now I set up the listener on the server first. And now we go to the first client, create the preshared key. We get the same warning, we have to delete the file later on. Now we look up at the what is it? The checksum. And now we transfer the key to the server with this command, and it with Control C. Now you see the listener hang off on the server, so it gets the information, and we can set up the preshared key in the peer on the client and save the configuration. And if we look here for the W status, he has a preshared key, and he cannot ping anymore the server because the server doesn't have the preshared key configured. Now we switch over to the server, and he gets the preshared key here. We check the sum here. We can do the same here. And you see it is the same checksum, so the transfer worked fine. And we can now set up. Now we do it later on. Yeah. Now we can do the same on the second client. We create again the same listener, but want to take the data into a second file. So we switch over to the client 2, create the preshared key here, ignore the warning again, take the checksum, Then we transfer the file content. Oh, there's something. Why? I know why. The listener is not running. Now the listener is running. And now we can transfer the file, the content. Control C will end it up. And we can check the checksum of the file on both systems. And it is the same. Nice. So now we can proceed on the second client to configure the peer with the preshared key and save the configuration to the config file so it's persistent. Now we go to the server and we have to configure the preshared key there. If we have a look at the status of the wireguard interface, you'll see no preshared key configured yet. So we do this with the next two commands. Look again at the status and you see there's a preshared key. Now we save the configuration and when we can delete all pre-files here and the same here and on the first client too. So we don't need to care about the writes anymore. And now let's synchronize the panes again. We ping the server. It works. We ping the first client. It works. And the second client, it works. Nice. That's what we wanted to achieve, I guess. So yeah, that's the way how to configure wireguard. If you don't want to go these crazy configuration stuff, you can use tailscale, and maybe the open source version of the tailscale server would be headscale. Have a look at it. I put it in the comment of the video. I hope you enjoy my little screencast. Give me a thumb up. Enjoy my subscribe my channel if you want. It's for free. And take care. Bye bye. See you next time.